Hello everyone, am I audible? Yeah. So hi, I'm Aditya Prakash. I work as a senior DevOps engineer here at GeekyAnts, and today we'll be discussing how do we leverage Ansible and how do we use it to simplify our infra and configuration management. So basically, today's talk does not simply focus on how Ansible works, how we write code onto it. It's rather how at GeekyAnts we have started using it and what are the different spheres we are using it at. So to begin, what was the problem statement? So when it comes to the problem statement, first of all, the major thing that we were looking at was automating infra and configuration management. So Ansible provided us a unified tool using which we can do both. Second thing is it simplifies scaling. How does it simplify scaling? For example, using Ansible, if we have infrastructure as code, and say for a use case, we want a pre-prod setup to go live, or maybe for a client demo, or maybe for just load testing to take place. So using the same code that we were running in staging or prod, in minutes we can execute that code and boot that infrastructure for pre-prod, and bring it down at runtime as and in the on the fly as well. Also, how has Ansible and some of our custom APIs has also helped us manage multi-cloud infrastructure. I'll be discussing that. I'm not be showing any hands-on demo, rather I have few recorded videos which I'll be showcasing today in today's talk. Next is reducing deployment time for familiar stacks. For example, a client comes up to us and maybe he wants us to deploy an EC2 instance with an RDS, a Redis inside a subnet along with a load balancer. And we create an Ansible code for them. So going forward, any client that comes up with a similar requirement, we don't take much time deploying their stack. We can use the same code, same templates, just a little bit tweaks here and there in the variables. We can boot up their infrastructure and manage their configurations. Last, here at GeekyAnts, we have been extensively using Ansible, that and it supports all types of automations, be it right from server audit to any manual work that we have been doing on any infrastructure or servers. We are gradually removing that and replacing that with Ansible. So what are at GeekyAnts we are using it for our client projects and also for our internal POCs and several products that we have. We are using it for infrastructure and configuration management, also for IT audit. I mean, generating reports, running security patches, and small upgrades on the servers. As Faz said, we have a data center of our own that we are running. So the management of those data centers and configuration management on those servers has become a lot easier using Ansible. Apart from that, and using Ansible, we have developed some custom solutions like database management and app env management, which is, we started few days back only. It's a work in progress, but I'll try to showcase as to give an idea around what we are doing. So just to begin, few minutes I'll take how to explain what Ansible is. So you can consider Ansible as an automation tool. In this example, you can see an Ansible instance. We feed hosts as in what servers do we want to run a configuration in, and in playbook we pass the roles, the tasks, whatever commands we want to execute on those servers or an infrastructure. We provide that to the Ansible instance. Ansible then, using the SSH protocol, executes everything onto the servers. When it comes to infrastructure, it goes ahead and deploys it onto the specific cloud provider. So basic Ansible terminologies. As I said, when it comes to configuration management, we need certain credentials like the server IP, what SSH key to be used, and what is the user using which we have to log into the server. So those information can be, that kind of information is present inside an inventory file. Next comes the roles and tasks. So you can consider, for example, let us take an example. We want to run an apt upgrade, apt update, Docker install, and an Nginx install on a particular Ubuntu server. So individual tasks like the update and upgrade task, the Docker installation task, and the Nginx installation task can be separate tasks, and this can be combined together in a role called as basic setup. And these roles are finally called using a playbook file, wherein we mention which playbook file we want to use, which roles we want to call to execute any required tasks. And lastly, what we have are handlers. So handlers are nothing but some kind of listeners. Say you want to restart a Redis service, you want to restart a MySQL service or an Nginx service. So whenever a change is made to a configuration file of any particular service, we notify the handler to go ahead and restart that service so that the new configuration is reloaded. So a basic Ansible file structure looks something like this. We have an inventory file. We have a roles in which we keep several tasks, and we have a playbook file. Everything in Ansible is plain YAML text, and it's really easy to code and get started with it. Now, how are we using Ansible for infrastructure as code? So basically, using infrastructure as code, first of all, is very beneficial whenever you are working on booting up any infrastructure, because of the fact that it is code, and when combined with tools like Git and version control, it's a very controlled environment in which we can go ahead and boot infrastructures with a number of approvals that whether the infrastructure is running or not before it goes on to production. So I can maybe this is one of the simplest architectures that one can think of: a virtual private section, a virtual private cloud in any cloud provider, a VNet that's booted, a server in the VNet in which we can access and we can access the server using SSH, a route table that connects to the VNet along with its connection to the internet gateway to provide internet to that particular virtual network. So I mean, this is one of the most basic infrastructures that we can boot on any cloud provider. So how are we handling it? So whenever a request comes to us, we simply don't go ahead and start writing vars file and booting running playbooks and start booting the application. What we do, until and unless the cloud provider is decided, maybe if the client wants that a staging environment to run in one particular cloud provider, and then later parts of the project he wants to migrate to a better cloud provider, we generally take information in terms of generalized vars. So what we have in generalized vars are simple login credentials for that particular cloud provider. We take general information like VPC name, which region you want to boot that in, your any particular subnet CIDR you want, SSH keys, the VM name, and VM specifications like RAM, CPU, disk, and all those things. And we have created a set of infrastructure APIs in which we pass the cloud and cloud name, and it just simply goes ahead, takes the information, and creates a var file for us. So as uh, you can see a difference in the number of vars file between AWS and DigitalOcean, because DigitalOcean will not take all the values from generalized vars, because we don't need to create uh, route tables and internet gateway when it comes to DigitalOcean. So we have created APIs that goes ahead, separates the vars, and creates this on the fly. Next, after having created those vars, what we do is, I'll show a demo for this. The code is available. The code is visible, right? I'll show the code just a minute. I'll increase the playback speed as well. So this is my main playbook file in which I call all the roles like VPC, internet gateway, route table that gets attached to the internet gateway, a subnet, and an EC2 role. Now, as you can see, this is the vars file that was created as part of the generalized. I mean, we called we called our custom infrastructure APIs, and this was the vars files that got created. So now, as you can see, this is the vars file. Now I'll quickly show you some of the roles that we have written. The VPCs. You can see that booting up any component in using Ansible, any infrastructure is very simple. Hardly few lines of YAML content, and we can start booting up the infrastructure. So you can see we have taken values from the vars file like the AWS VPC name. As you can see, very few lines of code, using very few lines of YAML content, we can go ahead and boot any and every kind of infrastructure. You can see that we have certain values mentioned here in quotes and curly braces. These are the values that are taken from our vars file that we created, and whatever output the Ansible code, when it boots up a VPC, whatever output it produces, it stores it in a VPC variable so that we can reference this VPC variable to boot other components inside of that particular VPC. So as you can see, very few lines of code we are using to boot up an internet gateway also. I'll quickly pass through the entire video. Uh, we are booting up a route table, and we are adding all the necessary records inside the route table so as to provide the subnet internet access. Later, we create a subnet and attach it to that particular uh, route table. Going forward, you can see that we are creating on top a pair of EC2 key pairs, and we are launching an instance using all the other information that we used ahead. Now I simply go ahead and execute my code. So whenever I'm executing my code, I'm passing the variables file that I want. And along with it, I'm passing the playbook file which contains all the roles. So now if I start executing it, here in the demo, I'll show that the components of the infrastructure start getting booted up, and I'll show the output on AWS console. So you can see when I refresh here, my VPC is booted. We are creating the EC2 key pairs, and now I'll log into AWS console EC2 dashboard, and we can see that we have a EC2 instance up and running. It's still in the initializing phase, and as soon as this comes into running state, my code execution will complete. So as you can see, we have got all the outputs. Our code has successfully executed, and we have the EC2 instance up and running. Similarly, as I showed before, we also have a set of DigitalOcean variables. So DigitalOcean, again, we'll be doing the same thing. I'll be showing you the playbook file. So the playbook file has, again, a set of all the roles that we need to call. These roles simply go ahead and create the VPC using these particular VARs, which we got as an output of our infrastructure general VARs APIs. We get the VPC detail. We create a droplet and print the result of the droplet in this particular result variable. Now, when we go ahead and execute it, this will start booting infra components on DigitalOcean. So now if we go into networking, we go into VPC, we can see my VPC infra component has been booted with an IP range being picked up from the VARs folder, VARs file. Now, if we go a bit more ahead, we can see that test droplet has started booting up. So this is how we are doing it here at GeekyAnts. We are taking generalized set of variables, and also we are gradually adding each and every infra component from each and every cloud provider, so that any and every type of infrastructure that comes to us, we are able to boot it in no time. So this has been saving us a lot of time for every client project that comes in. Next comes how we are using Ansible for configuration management and deployment. So here I'll be taking a basic example wherein I have a server ready. I'll be simply booting up a Docker container inside the server. I already have a to-do application that has been pushed to hello world application that has been pushed to a container registry. I'll be taking in that I will taking in login credentials for that particular ECR into my VARs file, and the certificates for my Nginx, and also the server name. So very basic information, and we have created custom roles around it that goes ahead and deploys the entire application. So if I log into the server now, I can show you that it's a pretty new server. I'll run the history command, and you can see the server is pretty new. Nothing is already running on the server. Now, this is my required playbook file wherein I call all the roles to do a Docker setup, to set up Nginx, and also roles to copy certificates and Nginx templates from my local onto that particular server. So these are some of the constants that we have been passing, like what is the part of the certificates and which path to go ahead and upload the certificates and the Nginx configuration template to. These are the Docker, these are the variables that we have been taking. For example, what domain name do you want? If you can see, the domain name here mentioned is demo.blr0.geekydev.com. And here we are taking a set of login credentials for our Docker container registry. Here we'll need an inventory file because we need to execute certain commands onto the server. We pass the IP, the root user, and the SSH port. So here I'll be showcasing some of the roles that we have written for installation of any package onto any OS. This is the bare minimum amount of lines that we need to write, and it will go ahead and install those packages. These are some custom roles which go ahead, install Docker, and set it up on the server. There are other tasks on this for custom roles that we have written for executing Docker commands onto the server, and these are some files that we are copying onto the server, which are the nginx template files and the certificates. Now, sorry. Yeah, so now I go ahead and start executing my playbook, and you can see this is still working. Just a minute, I'll fast forward the video a bit. And when I do a Docker PS, we can see that an application on port 3000 is up and running. Now my code will go ahead and do all the nginx required nginx configurations onto the file, onto the server. And now the demo.blr0 which we had passed, I'll hit that URL, and you can see that the hello world application is up and running. So any Dockerized application that comes to us, it becomes really easy for us to go ahead and deploy things on the server with some very little information on some variables like certificates, what is the Docker credentials, and the domain name that we want. So this is how we have been managing projects for clients. I mean, this is a very basic example, guys. We have done more complex and microservices architecture as well. We have deployed Kubernetes architectures also using Ansible, both self-managed and on cloud providers, and also certain serverless architectures using ECS deploy, and using maybe Docker Swarm as well. Then comes Ansible for IT audit. So just because of the fact that we have been using Ansible, we also introduced it to the IT team, wherein whenever we have to run small security patches, upgrade servers, upgrade the OS versions onto the servers, or maybe have a server audit report at the end of every month, which we need to see is compliant to the security and or not. So we have custom Ansible code, and this is how our maybe very basic server audit report which we get, which gets the OS data, whether Linux is disabled or not, firewall is running or not, what is the SSH port, what are the various interfaces and ports and applications running on the server, what is exactly the firewall data, so as to review if we have opened any unnecessary ports or traffic to any unwanted IPs. Also a list of users that have access to the server. So this has really helped us speed up the audit process. This particular automation has really helped us. Now there are some custom solutions that we have developed using Ansible. Custom solutions, the few of them being database as a service and the other one being env management. So first of all, why did we start developing our custom solutions? So we had certain problems for our internal projects where we were using servers like Postgres or MySQL. If any one of you has manually gone and set up live replication or master slave architecture for MySQL or Postgres, you would have seen that it's a lot of hassle. We have to do a lot of configurations on the master server. We have to reset the master, take some data out, copy the dump to the slave folder, make some changes on the slave folder, and then the replication starts working. But the major issue comes here whenever maybe there are some poorly ran migrations, or maybe there is some network outage because of which the slave breaks. So again, we have to do the entire process. So as to avoid that manual hassle we were doing, we developed something of database as a service. So what exactly we are doing here, I mean, it's not only for master slave architecture, it's for all the MySQL client processes, like adding, removing privileges and everything. I'll quickly show you a small demo for the database as a service which we have developed, and I'll be showcasing the master slave architecture. So I have logged into my master. You can see that MariaDB is not installed onto this. I've logged into my slave. You can see that even this is a brand new server with nothing running on it. So here we have a simple shell script which calls the Ansible code, which takes in my inventory file, my vars file, and my playbook file, and I go ahead and execute it. This is my main playbook file for my master server, wherein the first role goes ahead and installs MariaDB. The second one makes the node ready so that it can act as master. And the last one takes the information from that master, which information can be fed into my slave node. We have a similar setup for the slave node as well. These are some of the basic variable files which are mostly constants, and you can see that certain values get self written on the fly whenever we have started running our playbook files. So I'll quickly go ahead in this. I'll quickly fast forward the video, because again, nothing we have done. Whatever shell, whatever scripts that we used to run manually, we have added that to our basic Ansible YAML files, and we have started executing those. So as you can see, Ansible code has started running. It's showing me all the live logs that are happening on the server and the log that Ansible is generating. You can see master, whatever files, that the bin log position files and all those things we have got as output of Ansible, which now Ansible takes as an input for my slave node. We'll wait for the completion of this particular playbook. So now, as you can see, the pipeline, the Ansible playbook files have successfully ran, and it has returned us that both the inputs for slave IO is up and running. That shows that the master slave architecture is active right now. So now I'll log into my slave and I'll show you the live slave status for this. You can see both the yeses here. That shows that the slave is up and running. Other places where this has helped us is scaling. So whenever it comes to scaling, say adding an additional master node, or in most cases what we get the request as is addition of additional slave nodes, what we can do is we can go ahead and simply update the inventory file, and our application will go ahead and boot the entire master slave architecture. Even if a master slave architecture is up and running, we can go ahead and add slave nodes on the fly. So this is, we have developed this for both Postgres and MySQL, and mostly for projects where bare metal database management is required. Next is something called an app env management. And why did we start doing this? Again, we started this because we were facing some automation issues for our applications that were running on our bare metal servers. So for example, an application is running on our bare metal server, and we have RDS instances maybe running on AWS, MongoDB, Atlas, that is booted somewhere outside. And all this booting up, we are only doing with the help of our infrastructure as code. But we wanted a singular place where we could store all the secrets. So what we found out, that mostly for an application, whenever we are booting it with the help of our Ansible codes, we are getting in variables from three different places. The first place is the initial vars file that we pass, because whenever we boot an RDS, we pass the what database we want the name to be, what is the password that we want, all those things, like the port, app, what user do we want to boot up. All those things are a part of the first set of variables. The second set of variables which we get are a part of the output of the infrastructure that we get. For example, we have booted an RDS instance, we have booted a Redis instance, so we need those URLs. So that gets added. So we have created a sample template like this, and we have some third party environment variables like the Google API key, the JWT secret key, and all those things. So we have created template like this, and what we have also created APIs which takes values from all these three places and creates the app env for us, which we can store in one singular place on our Ansible master node, and which can be fed to applications when they move on to deployment. So these are some of the things that we have developed using Ansible and started using it. I believe that there are still places where we have to improve, like go ahead and improve our APIs, our templates, go ahead and add more and more roles for every other infrastructure component for any cloud provider solution. But yeah, we have started delivering this, and till now it has saved us a lot of time, and the standardization has come into picture for our team. So this is it from my end. I'm questions.